If you don't understand why Java was created, you will never fully understand how Java works, and that confusion will follow you into interviews, backend development, and system design. Today we rebuild from zero. Why Java needs to exist. The 90s platform problem, bytecode plus JVM revolution, security and memory decision, enterprise design trade offs, interview architecture clarity. I will be honest, I studied Java in BC and MCA. I write code, I pass exams. But I never asked why was Java created in the first place. That gap created confusion later. So now we rebuild properly. Before learning syntax, we must answer why did Java even needs to exist? What problem was it solving? Why didn't C or C++ solve that problem? Why do companies still rely on Java? If we skip this, Java becomes just another language. But once you understand its origin, everything about JVM, bytecode, memory, oops, security start making sense. Interviews often test this indirectly. Why is Java platform independent? Why is Java secure? Why is Java slower than C? Why is Java used in enterprise? If you don't know its origin, you memorize answer. We are not memorizing, we are rebuilding. Java is high level, object oriented, platform independent programming language, designed to be simple, secure, portable, robust, and scalable. It was created in 1995 by James Gosling and his team at Sun Microsystems. But that's not enough, we need context. Let's go back to early 90s. Computers were different. Windows machine, Unix systems, embedded devices, set-top boxes, early internet systems. Programs written in C or C++ were platform dependent, meaning if you wrote a program for Windows, you had to rewrite or recompile it differently for Unix. This created massive compatibility issue. Manual memory management caused crashes. Pointers misuse caused security vulnerabilities. Software portability was painful. Sun Microsystems started something called the Green Project. Goal was to create software that could run on different devices without rewriting. Initially, it wasn't even for the web apps. It was for the embedded devices. The language was first called Oak, later renamed to Java. Now comes the revolutionary idea. The core idea was simple but powerful. Instead of compiling code directly to machine code, compile it into an intermediate form. That intermediate form could run on any machine that had a virtual machine. This became bytecode plus JVM. Java code compiled into bytecode. Bytecode runs on JVM. JVM is Java Virtual Machine. This is what created write once, run anywhere. That is VORA. Instead of rewriting your code for every OS, you just install JVM on that OS and the same .class file runs everywhere. That was revolutionary. Now let's break the important pieces clearly. First is high level language. Human readable syntax closer to English than machine code. Example, in Java we write system.out.println hello. Much easier than assembly. Second is object oriented. Java was designed as an object oriented language from the start. Everything revolves around classes, objects, encapsulation, inheritance, polymorphism, abstraction. Why? Because large systems need structure. Procedural programming becomes messy at scale, and enterprise softwares need maintainability. Third is platform independence, achieved using compiler, that is Java C, bytecode, and the JVM. Architecture is source code, then your compiler, then your bytecode, then the JVM, and then the machine code. JVM converts bytecode to machine specific instructions at runtime. Fourth is automatic memory management. In C or C++, you manually allocate and free memory. In Java, garbage collectors automatically removes unused objects. This reduced memory leaks, crashes, and pointer errors, huge for enterprise systems. Fifth is your security model. Java removed direct pointer manipulation, unsafe memory access, plus bytecode verification, class loader isolation, sandbox execution, especially for applets back then. Security was built into the architecture. Now comes step-by-step technical flow. Let's understand how Java actually runs. First, you write code in .java file. Then, compiler, that is Java C, converts it into .class file. Now, .class file contains bytecode. After that, JVM loads the bytecode, and the bytecode is verified for security. Now comes the JIT, that is just-in-time compiler. It converts frequently used bytecode into machine code. and now your program runs successfully. Important information is that Java is both compiled and interpreted. Compiled to bytecode, interpreted or compiled at runtime by the JVM. This hybrid model balances portability plus performance. Now, why should you choose Java? Enterprise backend system, banking software, large distributed systems, Android development historically, and big data tools. Trade-off decision: safety plus portability over raw speed. Pros: stability, scalability, large ecosystem, strong typing, massive community. Cons: more verbose than Python, slower than C++, more memory usage. Java choose safety and portability over raw speed. Why do big companies still use Java? Because JVM optimization are mature, huge ecosystem, Spring and Hibernate, long-term maintainability, strong concurrency support, backward compatibility. Banks in India and the US run mission-critical systems on Java. Why? Because stability is greater than trend. Now let's talk about real-world application. Java powers enterprise backend system, microservice architecture, Android apps, earlier code language, big data frameworks. For example, frameworks like Spring Framework dominate enterprise backend. Android originally used Java heavily via Google's Android SDK. Even today, JVM based languages dominate backend hiring. If you build REST API, banking system simulation, e commerce backend, student management system, understanding why Java was built helps you. First, explains architecture choice. Second, justify JVM usage. Third, decision scalability. Fourth, talk about memory management. That makes your resume stronger. Now let's see from interviews perspective. Common questions. First, why is Java platform independent? Second, what is JVM? Third, difference between JDK, JRE and JVM. Fourth is, why is Java secure? And fifth is, why is Java slower than C++? What interviews testing? Do you understand architecture? Or do you memorize definition? Model answer structure is definition, then mechanism, then design, then reason, and the last is trade-off. Common mistakes. First, thinking Java is interpreted only. Second, thinking Java is fully compiled like C++. Third, not understanding bytecode. Fourth, ignoring JVM. Fifth, memorizing Vora without understanding how. Most confusion in advanced topics comes from this gap. Now the best practice. When learning Java, always think in terms of JVM, understand memory model, don't ignore architecture, learn why features exist. If you know why, you never forget how. Now, here's something important. If Java was created for portability, why do we still sometimes face "it works on my machine" issue? That's because JVM versions, dependencies, and environment configuration matters. We'll cover that when we go deeper into JDK and JVM. Layered summary. Basic level. Java is high level object oriented, platform independent language. Intermediate level. Java compiles to bytecode, runs on JVM, and ensures portability. Memory management via garbage collectors. Advanced level. Java was designed for portability, security, scalability, enterprise reliability. Its architecture decisions still shape modern backend development. I used to skip this, I used to jump straight into syntax. That's why I stayed confused. But now we are rebuilding properly. We are not behind, we are just fixing the foundation. And that changes everything. If you want to truly master Java, not just pass exams, stay with the ZeroGap roadmap. Next, we'll go deeper into the JVM architecture and break it completely. We are not rushing, we are rebuilding.